Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome, everybody, again to another episode of our show. Today, bringing you another really fascinating individual involved in creating a better tomorrow for all of us. And we're headed back again with our friends at Microsoft, profiling another really cool rising star in their artificial intelligence, machine learning organization. I have the honor today to be joined by Advitya Gemawat, who is a machine learning research engineer, currently works in their responsible artificial intelligence team as part of their Azure Machine Learning and Azure AI Studio product lines. Prior to this team, he was part of the fourth cohort of the Microsoft AI Development Acceleration Program, or MAIDAP, which we talked a little bit about on previous shows. There he worked with Azure Quality, Microsoft Gray Systems Lab, Azure Edge and Platform, and Azure Machine Learning. And his research experience is this really interesting intersection of machine learning and scalable systems, and we'll be getting more into that. His work with the Microsoft Gray Systems Lab was identified as the Microsoft Global Hackathon Executive Challenge 2022 winner and the recipient of the Best Demonstration Award in 2022. And his work on the team of expanding the responsible artificial intelligence dashboard to support various object detection models was recently released for public review in Microsoft Build 2023. Prior to Microsoft, he graduated from UC San Diego with the data science major. There he contributed to a project known as Project Cerebro, a really interesting layered data platform for scalable deep learning, which we'll get a little more into. A lot of really interesting themes and topics, and of course, he comes with it. Despite his young age, he has won numerous awards over the years, and prior to UC San Diego, spent a little time at VMware as well, and there his work on massively parallel automated model building for deep learning was included in their Apache MADlib release. A lot of interesting themes to get into, another really interesting story and guest on the AI front. But Advitya Gemawat, thank you so much for taking the time to come on the show today.
Yeah, thanks a lot for having me, Ira, and looking forward to chatting with you, and hopefully some of the content will be engaging to your audience.
Absolutely. And again, I enjoyed reading about you and everything you're up to. Would love to, though, start off, as we typically do, by handing you the floor for a little bit. I had a chance, and for everyone watching and listening, Advitya has a YouTube channel of his own where he exposes the world and folks like myself to some of the more basic concepts that he's involved in. But take us back a little bit. Talk about your early journey. I know, you came to UC San Diego, I think your first time in the United States, and of course right into a very tough program, and talk a little bit your background and ultimately that early part of the journey, if you would.
Yeah, of course. So it starts with a funny story, because I applied to UC San Diego with an engineering sciences major, and I got into that major for UC San Diego. 10 days after my admission offer, that major got canceled.
Ooh.
Don't ask me why. I still don't know to this day. And I just automatically got structural engineering as my major, kind of a more specialized part of civil engineering, but also interdisciplinary. So I entered college with that major. I took the first class. but I couldn't see myself in that area as much. And I really liked math in high school. And I had never done computer science before, but I knew that programming was pretty important, kind of a skill for the future. And I just thought to myself that if I can combine my interest in math with something like computer science that might be more in demand in the future and something that would be more valuable to the industry, that would probably be the sweet spot of what I may want to pursue and contribute towards. So I ultimately wanted to change majors and boiled down to two options. The first one was basically a math and computer science major. The second one was data science. Data science was the new major that was introduced at UCSD when I was a freshman. And at least at the time, it was very rare for colleges in the United States to have a data science major in their undergraduate program. So ultimately, I came across that major, saw the coursework, spoke to a lot of faculty and recruiters and hiring managers and upperclassmen. I even did a few online courses just to dip my toes into what this kind of work looks like. And ultimately, I found the work very fascinated and got into the major. And pretty much throughout my college, after getting into the data science major, I got to kind of work for like a volunteer for a student run startup, and did a bit of research and did internships in companies across different industries to get more exposure on how data science is applied in those different industries, and also transition to then ML engineering in terms of building software for better data science. Kind of an interesting journey, in my opinion. There are lots of diverse things that I could learn. Yeah.
Absolutely. Yeah, that must have been scary after the first 10 days but nonetheless, you ended up, as you say, in a very important sweet spot. Talk a little bit about, because I mentioned in your bio, one of the things that you focused on when you were at UC San Diego was this Project Cerebro, and you wrote you were involved in a couple peer-reviewed publications on the topic, sort of broadly talking about this, at the time, this issue of scalability of this deep learning, and ultimately sort of, it was a couple of years ago, but still, this thing has been accelerating so quickly. Introduce us just a little bit what's going on at the time, what some of the pains and issues are with scalable deep learning. And then if you could take us through, because part of one of the papers I looked at you published had to do with a collaboration between your team with Cerebro and the University of California, San Diego public health researchers, which were doing all sorts of interesting stuff with wearables and data and crunching numbers that you needed deep learning for. Talk about that story as well. I think it's a really interesting piece of what you're involved in.
Of course. Project Cerebro was a pretty massive initiative with the research lab that I was working on, which focused on building an entire layered data platform to do deep learning at scale. So just to provide a bit of context, deep learning would usually be performed on unstructured data sets like images, text, audio, etc. And deep learning models would be surprisingly powerful, but also very, very expensive in terms of their number of parameters and the amount of mathematical calculations that would happen to train these kinds of models. Pretty much what this lab dealt with was building better machine learning systems that are cheaper, faster, more scalable for these applications in general. So they looked at a general variety of problems, and at that time, obviously times were quite different than what they are now. And at the time, transfer learning, for example, was gradually becoming a rage, which basically means reusing the expensive components or the expensive parts of a model, and then kind of reuse those parts for similar kinds of applications, rather than crunching all of that huge amount of data again, just so that you can save a lot of compute and time and money, right? And pretty much the particular project that I was involved in involved transfer learning and involved convolutional neural networks, or CNNs. Basically, it's a kind of neural network to analyze image data and do predictions on it. And we basically got to look at the training life cycle of a CNN. And we saw that the way that the model is trained has a lot of redundancy in how the calculations happen, where, say, it has a lot of layers, and each layer captures different kinds of features or attributes about the image. If you have, say, 4 layers, A to D, and if you have to get layer C, you'd have to go through the calculations of layer A, and then layer B, and then layer C. So rather than kind of going from start to that layer every single time, which is very suboptimal and wastes a lot of compute, repeats a lot of computations, we essentially looked at that problem and say, okay, we can perhaps cache or save intermediate computations and reuse them.
Sure.
And that was kind of an optimization that had far-reaching advantages to all kinds of applications potentially that may involve these kinds of neural networks. Now, this was one area, one theme that I had dabbled onto for research. But the broader idea of Cerebro was basically to create this layered data platform where we would bake in these optimizations at the heart of how deep learning models would be trained. And on the user side, we would just expose to them a bunch of declarative ways or easy ways for users to just specify their inputs. Okay, I want to train this model on this data and things like that. And this is the memory in my machine, this is the RAM, etc. Do this in the most optimized way possible. So as much compute and time you can save, the better it will be, right?
Mm-hmm.
So we tried to kind of make it very clear for the users to simply declare all kinds of details about their model and data and compute and training setup. And we basically handled all the heavy lifting in terms of converting those user inputs to actual optimizations tailored to their specifications. And I'm also glad that you stated about the collaboration with UCSD's like public health institute as well. So there were these different research labs across UCSD that were doing various kinds of research. And in one of these examples, they were actually able to use the Cerebro system to optimally train some of their networks for some of the biological analyses, DNA stuff, etc., that they were doing. So we were also able to see the benefits of these optimizations and also their applications across these diverse areas as well.
Excellent. So, following, your time at UC San Diego, you arrive at Microsoft, and you were you became at the ripe old age of 21. You become a member. Well, you're the youngest member ever of the fourth cohort of the Microsoft AI Development Acceleration Program, or MAIDAP, and Reshmi introduced us to her experiences a couple days ago. Take us through your MAIDAP story, if you would, a little bit about I guess applying to the program at such a young age, and a little bit of because I mentioned in the bio, you've been involved per MAIDAP in Azure, this interesting Gray Systems lab. You've been on this hackathon stuff. Take us through what those couple of years were all about, and how important that model in terms of sort of this internal rotation process was for building up what you're becoming the last couple of years.
Of course. Yeah, it was an amazing experience. And so the way I got to MAIDAP was kind of, in fact, through this research lab that I was working in. And the professor of that research lab had pretty close ties with the Gray Systems lab at Microsoft.
Okay.
So I just reached out to the head of Gray Systems lab on LinkedIn at the time, just introduced myself, that, hey, we know this professor, we have had this collaboration, and I was interested in this program. And he happened to have known the hiring managers of that program. So I was able to kind of build some of those relationships to also get an interview. And getting into MAIDAP was a huge kind of honor for me because I had never come across a program of this kind before. Basically, a rotational program, specifically in machine learning for early in career folks across these different disciplines at one of the biggest tech ecosystems on the planet. So I was very, very excited about like hearing about these different projects and getting that bird's eye view of the different ML challenges that Microsoft tackles in general, not just in my projects, but also hearing from other people.
Sure.
Probably one of the best parts about this program were the people. There were people from really diverse backgrounds, from different degree levels, different areas of specialization, and really collaborating with them and even just hearing about their projects and how they're working with certain orgs of the company was also very, very interesting. In my case, so I had worked with different orgs across Azure, and I had worked with Azure Data in the Gray Systems Lab. I had worked with Azure Edge and Platform twice in different teams, and also Azure Machine Learning, the current team that I'm actually in. So by dabbling into these diverse areas, all from machine learning systems research to AI for IT operations to responsible AI, I kind of also got a good kind of intro on these different challenges faced across the company and got some diverse experiences in applying ML in different ways and looking at the ML life cycle in different ways as an engineer as well, in terms of how to build the corresponding infrastructure in a better way, depending on those use cases and things like that. So, and yeah, a very special experience because a lot of young people, a lot of very strong group cohesion. And kind of this fun gig of, switching a team every 6 months and exploring new projects.
And one of the areas that you've been publishing a bit on, I guess that comes out of the program has been this topic of tensor data, which I took a little time to read about, which is, you could describe it in more detail, but these really interesting data matrices. And you published a couple of papers recently, one that's titled The Tensor Data Platform Towards an AI-Centric Database System, another one, Share the Tensor T, How Databases Can Leverage Machine Learning Ecosystem. And you talk a little bit about, while a lot of the excitement recently has been on sort of the data centricity of artificial intelligence, you in the paper talk about the reverse of that, the artificial intelligence centric database. Talk a little bit about what you've been up to on this particular front, because I know it's been you've been writing a lot about it, and I think it's an interesting piece of, again, your story.
Yeah, of course. So that work kind of also was one of my rotations that I had also dealt with, and it's a very profound idea, I feel, which bridges these disparate worlds of artificial intelligence and the traditional world of database systems. Database systems have obviously existed in like a huge production front for decades now. And when we were looking at these artificial intelligence frameworks like PyTorch and TensorFlow, which enable us to train some of these models, there were a lot of these modules were built like at industry grade. These modules were great. They had a lot of baked in optimizations depending on hardware, depending on your particular model, and there were a lot of runtime benefits, a lot of quick optimizations to train these models in a better way. And we kind of thought to ourselves that these modules are able to accelerate these computations by effectively utilizing the hardware where they're trained on, whether it be a CPU, GPU, etc. And the initial thought that the lab had was, can other kinds of data computations, not related to deep learning at all, can those other kinds of computations potentially reap the benefits of all the parallelizations and all the optimizations that have gone into creating these systems? In other words, can we express other kinds of data computations, just in general, not even related to AI, but can we express those computations as a sequence of these tensor computations that these modules like PyTorch and TensorFlow are built upon? The tensor is kind of the basic abstract unit that these modules are built upon, and all of these optimizations are kind of built on top of the tensor framework, a particular way of representing data. So it essentially was an idea of potentially converting a different kind of a data computation to a tensor computation so that that data computation can automatically reap all the benefits and optimizations in these systems and potentially execute quickly and save time and money. And so initially they had done work with traditional machine learning models that were not based on the tensor abstraction. And we kind of went a step ahead and said that, okay, there's a lot of data being crunched by databases, by SQL queries where users may ask questions to data and they may get answers, right? Can we express those traditional relational algebra-based computations in the form of tensors so that could those computations be potentially accelerated by the hardware that they run? And this opened a Pandora's box of opportunities in terms of how we can accelerate database computations and what kinds of interesting features originally built for AI could be reused for databases. And there were a variety of ideas that we explored, all from converting those database computations to tensors, running these kinds of database queries on the GPU, which was almost unheard of before, also using AI visualization tools to visualize the performance and execution of a database query, and all from even exploring different kinds of queries which may combine relational operations like typical filters on your data to even machine learning computations and seeing if these diverse kinds of data computations can be represented in a single unified format and be globally optimized. And so this Pandora's box really was this broad initiative that I and a lot of other people got to work on and got to present our work and demos on. And I feel this profound idea has a lot of potential in terms of transforming innovations in the database systems, which historically have been very compartmentalized, very specific and niche to particular databases, and actually introduce more uniformity, more industry-grade practices to the process, and enable us to reuse a lot of the existing work and optimizations that have been invented in this different land of AI and bring that to the
Really excellent. Talk a little bit, if you would, about responsible AI, what it means in sort of your day-to-day. Because again, I mentioned in the intro that you were part of the responsible AI team per the Azure Machine Learning. Recently, there was an article in Microsoft Tech Community sort of highlighting all of this, and it's entitled "Debug Object Detection Models Responsible AI Dashboard," and it sort of goes into all the sort of the sensitive issues when again developing some of these systems and models. Talk about responsible AI. Talk a little bit about this particular project for the object detection, and then just the role that sort of responsible artificial intelligence and the ethical parameters at Microsoft play in your sort of day-to-day activities.
Yeah, of course. So yeah, responsible AI is an incredibly broad field, but basically what it broadly means is to develop AI in a way that is safe, reliable, ideally free of human biases, and basically does not cause any harm, any unintended harm to the users that are using it. That's kind of the broadest definition in my mind. And what I have kind of seen and learned with this area of responsible AI, there are we have also tried breaking down this problem into a couple intuitive parts related to identifying or diagnosing what kinds of challenges could the machine learning model be prone to, or what kinds of issues could the model be prone to, identifying those problems, trying to find mitigations for those problems, and actually implementing those mitigations to improve the safety and reliability of those machine learning models. And so obviously, because machine learning is such a diverse field with so many different tasks, responsible AI obviously would also become very diverse, depending on the task at hand, depending on the context of the task and things like that. What I particularly dabbled into was during my last rotation, I worked with the responsible AI team in AML in Azure Machine Learning, which I'm also a part of now after having done the rotation program. And we particularly worked on object detection models. Basically, what object detection models mean is you have an image of different objects, and not only do you identify the objects in the image, but you also draw bounding boxes around the objects to exactly pinpoint where those objects are. And these models are used in a variety of applications, all from self-driving cars or autonomous vehicles to detecting tumor or diseases in X-rays, things like that. So very diverse applications there. And for these different applications, we pretty much looked at some of the main questions that let's say, our customers had were surrounding how do they understand errors of the model in a better way? How do they understand the behavior of the model in a better way in terms of why is the model making the decisions that it is, and how to potentially correct those decisions? Deep learning models in general, these kinds of models in general are notoriously difficult to explain traditionally. So now a lot of research and ideas have come up where there are different techniques that we try to employ to provide better insights to our customers on where this model could potentially be unsafe or where this model could potentially be weak so that you can correct it. And this can start initially from just accuracy metrics. This can evolve into better metrics. This can evolve into group-based metrics of particular groups that the users would care about more. For example, even if there are 99% of emails in your data that are not spam and 1% spam, you probably really want to make sure that the accuracy with that 1%, that sliver of the data is probably a lot more important in several cases. Mm-hmm. So trying to get those group-based metrics, and then depending on task, in our case, we had these object detection image models, trying to even create different maps which are of, say, these different colors that would be superimposed on the raw image to show which parts of the image is the model focusing on more versus less to make its prediction, to identify the object, and how confident is the model in doing that. Mm-hmm. There are also several other branches that intersect with responsible AI related to analyzing specific errors in your model, related to counterfactuals or particular kinds of causal techniques as well, related to fairness and interpretability or explainability. So a lot of these areas is what this team kind of deals with. And we also kind of got to learn about and implement some of these techniques to provide users with more fine-grained insight on the behavior of their model so that they can potentially correct the model based on the context of their task and based on what they care about for their models.
You recently sort of graduated from the MAIDAP program. what's next? I mean, it's interesting because I came up, when I was again reading all about you. There was an article a couple of years ago in the Data Standard that highlighted sort of the top 25 people, data scientists to watch. You're listed as number one back then in 2019, 2020. What's happening next? I mean, obviously you're doing so much. You've I neglected to mention you also collaborated with groups like Hewlett Packard early on during your undergraduate education. I mean, obviously you complete the program you see in San Diego. You're completing the program here at Microsoft. What should we be on the lookout for you for the rest of 2023 and in the coming years? What else are you up to?
Of course. First of all, and I just want to clear this up, I was listed as number one on that article because it was in alphabetical order. I'm just saying, okay?
I give you the credit.
But yeah, but yeah. So after I just finished the MAIDAP program, dissertation program, a couple of months back in June, and since then I have actually joined the responsible AI team in Azure Machine Learning, and the scope of my work has definitely increased from initially just working on object detection models to now working on image models in general. So I'm kind of am starting to, in a way, own a bigger piece of the pie in terms of unlocking our AI insights for them. We recently saw in Microsoft build in June of this year, where the image and text dashboards for the responsible AI dashboard on Azure Machine Learning was released in public preview. And there are additional features that customers and users can also keep an eye out on. One really cool thing about my work, in my opinion, is a substantial amount of work is open source. So the dashboards that we're creating are not just available in the Azure Machine Learning product, they're also open source. Literally, any open source developer can go to the Responsible AI Toolbox repository on GitHub. They can clone the repository, walk through those examples, and simply plug in their model and their data, and they will get a custom dashboard based on their particular use case, which provides just out of the box a lot of different insights related to how to improve the safety and reliability of their models. So there's also a pretty good amount of commitment towards the open source community in terms of getting responsible AI to be a first-class citizen in the machine learning lifecycle, and not just an auxiliary thought. And so, at least in the next upcoming months, a lot of the work that I've been doing is kind of open source on GitHub. So customers can, and even open source developers can take advantage of those new features, new responsible AI insights as soon as we get to implement them. Aside from all this work stuff and all the open source and external facing work related to the responsible AI dashboard, personally, I have been quite passionate about talking to college students and early in career students, and trying to bring them in to this fairyland of this area of AI, and different areas in AI, considering how exponentially fast this field is growing. So I also have the privilege to interact with a lot of college students, not only across in UC San Diego, but also just across the US in general, and talking to them about their experiences and sharing my perspectives, and giving talks all around. So in the next month or two, I also plan to visit a university in the Massachusetts area, and also give a talk to the data science students there. So a lot of those updates will for sure be surfaced on my LinkedIn profile and also on my YouTube community post as well. So can definitely keep an eye out for that as well.
Yeah, I was noticing again when I was looking through your your non-Microsoft activities. As you mentioned, you're involved in a lot of mentorship, volunteering work, and you've been a guest speaker on some different podcasts. And then I also saw this book, Ace the Data Science Interview, that you were involved in editing several of the different chapters on machine learning, data manipulation, and so forth. I mean, it's awesome that you're again giving back knowledge at such an early stage of your career, and it speaks volumes about you. For the sort of the next generation that we hope is listening to this show, and I joke that I have my 3 kids here that I make listen to the show. A couple words, if you would, to this audience in terms of AI, ML, data science careers, things that they should be doing early on in their undergrad experience. Any other advice you want to send out there while we have you, please?
Of course. I feel there were, and this is probably going to be a kind of a very specific response in terms of what I tried to follow in college, if this provides any insight. And I feel some of the rules of thumb that I had in college, I felt were pretty beneficial to my experience and getting more opportunities. First, I tried attending events at college as much as I possibly could. So I would just look at various kinds of websites inside the college, and if there were any alumni talking, if there were any companies coming in, etc., I would try to go to as many of those networking events as possible to not only meet people and expand my network, especially in my case as an international student who didn't really know anyone here in the US, but also in terms of hearing from more experienced people, a lot of different people, and trying to find patterns in what they're saying to actually pull something from their insights, pull those common trends, and try to actually do those online. By attending so many events of various kinds, one major insight that I got from those people, even across different fields in tech in general, was building your brand and having a solid network is really, really key to distinguishing yourself from the rest of the crowd. College students, to be quite frank, don't have any credibility of their own through no fault of theirs. It's the design of the process where they just graduated high school and just got into college, and they simply don't have any industry experience, because of which we simply never had much credibility when we were in college. So it was really on to us to build our network and brand ourselves in a way that communicates credibility and try to get opportunities where we could showcase that we have had business impact, where we could showcase that these companies and these organizations trusted us with their data science work, and kind of being active in the community, say through LinkedIn or these other channels, and engaging in these different in-person events so that you can form a distinct identity of your own. Mm-hmm. And that has far-reaching benefits in terms of you reaching out to someone and say someone looking at your profile before judging if they would like to spend time with you or talk to you or guide you through potentially getting opportunities and helping with referrals and the other mechanical parts of the job search process as well. So really the 2 major insights that I had in college that I would encourage anyone to do, regardless of field, is pretty much to explore as many events as you possibly can and building your brand and networking. And in terms of AI, I don't have like advice that would be radically different from this, because this was kind of the fundamental. But something that I also did aside from this is to get started on these experiences, rather than me waiting for an opportunity or me having a blank resume, I just tried to learn as much as I could. I took online courses initially to get the basics in, and literally my first resume ever was just a bunch of online courses listed on my resume, and a good GPA. So basically just that kind of helped me get my first job, first opportunity, and that kind of made it easier for me to build my profile and proceed forward with that. So we can also take it upon us to generate those opportunities for ourselves, learning those concepts, getting further opportunities, and being active with sharing what we're working on to communicate that passion and to also communicate that credibility that we have kind of had in our work and the kind of impact that we have created. And gradually things will start to work.
Yeah, I mean, you definitely are an excellent communicator, and clearly have passion for this area. And I'm a big fan, rooting you on as you continue on this journey. One last thing while I have you, I mean, you mentioned before you're going to be visiting some universities, doing some outreach in the coming months. I noticed that there were some conferences. I think the conference on innovative data systems research earlier in the year. Any other upcoming public-facing stuff, conferences, talks you're going to be giving, any place that we may bump into you and meet you, possibly, anything that I missed, please take the floor.
Yeah, of course. So yeah, I definitely plan to attend a university and give a talk there. Aside from that, there are also some conferences that are coming up where some of the work that I've been involved in recently may be showcased as well. So we will also kind of update those at the right times as the details get more solidified. Pretty much all of these major updates can be found on my LinkedIn, my Facebook, and YouTube, and I can provide you with the handles and we can share them on the recording. And yeah, that's pretty much kind of the two major areas that I feel very passionate about is, of course, showcasing my work and trying to engage with the community. So all of those updates will kind of be communicated as they come. Yeah.
Awesome. Awesome. And we will put all those links in the bio of the show. For everybody, again, that's going to be listening to this particular episode of our show across the various podcast networks, watching on our YouTube channel. Again, you've been listening to Advitya Gemawat, machine learning research engineer, responsible artificial team at Microsoft. Advitya, I want to thank you again for taking the time out of your schedule, talking to us, educating us about what you're up to. Obviously, thanks for everything you're doing in the world of artificial intelligence as it evolves all around us. And as we like to say on our show, thanks for helping to create a better tomorrow via what you do in the STEM field. Really very exciting story, and wishing you the best with all of it.
Yeah, thank you very much. I really appreciate it. And hopefully this was also engaging to your audience.
It definitely was. Great seeing you.